So how does MSW like prop itself up in front of the network? And like how is it able, because like I can imagine how you might do that for just fetch, but doing it for like all the different types of APIs seems like it might be a bit harder.
Yeah, it is actually hard, and I'm really excited to talk about the interception. So let's go. So, of course, like to handle a request, you need to intercept that request, right? You need to gain
Mhm.
control to catch it before it's actually made, because that's the whole point. And MSW does this slightly differently based on the environment. So in the browser, and this is where it started. It was initially it was a browser-only tool, and it started as an abstraction over service worker. So thus the name. And the whole point is that we have the service worker that lives alongside your application, and by design, that API can intercept traffic. So you can write your own handling in the worker, and then you usually use that to cache assets, to maybe deal with some progressive enhancement, like offline capabilities in PWAs were achieved mostly through service workers. So it's a fantastic API, but it was never quite used for mocking because kind of tedious. If you try to do it just in the worker, which I did like 7 years ago, you quickly kind of meet the ceiling because that's not much you can do there, and you have a very strict scope to comply with all the security considerations. So what MSW does, it uses the service worker that it registers just as the interception mechanism, and then it routes all the requests through the main thread, through your app, where you have these request handlers defined. So it's your favorite tools, your favorite language like TypeScript, your third-party libraries. It doesn't matter. Basically, it's your app, but the worker acts as a source of network. And I think it's a real nice way to put it, because when we go to Node.js, it kind of changes a little bit because there's no service workers there. And what we have to do, we have to catch the requests in a more conventional way like people used to do, like global.fetch equals my new fetch. But being more considerate about what those interceptors do to your codes or to your test, for example. So what we have a standalone library called interceptors, which provides this request agnostic, request client agnostic way, and translates all the different requests in Node.js to fetch API requests. And that's mostly down there, but it has a very clear responsibility. Like it doesn't do any route matching. It's a very simple tool, and I actually built it to be a low level library so anybody can build their own MSW on top. Because what I've learned from all these years of building API mocking tools, it is really hard, especially in Node.js, to implement consistent but also seamless interception. Usually it's quite primitive, and it hurts a lot because you just replace a lot of the native code, native network code, and you just interface with the mock more than you interface with that code that's going to run in production. So what we do, we iterate on this intercepted library, and I think last year, we did some seventh or something iteration, and this one is the most spectacular yet. I sound like an Apple commercial, but it's the best interception yet, because what we did with the help from contributors, we created the algorithm that kind of intercepts requests on the socket level. So we go even deeper down. So a quick overview, like you make a request in Node. Most likely you're making it through the HTTP module and using client request or just HTTP dot request. So you have this layer, this is your app. Then it creates a client request under the hood, which you're probably not creating manually. It's quite verbose. Then that client request creates a socket that's going to be your tunnel to transfer the data. And then that socket sends and receives packets or packages, and then it routes them through the parser, HTTP parser in this case, because we're dealing with HTTP requests, and then it implements all the request handling and responses. So we used to sit in the middle for a while, for a few years. So we were on the client request level, which is also how most of the Node.js mocking libraries work. They replace the client request. It's a good middle ground to inject yourself into. But then it was bugging me like, we can do better. We can do much more if we can just lower this logic to the socket level. But for a long time, it was kind of impossible to do, because once you're on the socket level, you don't have even the protocol context. Sockets can be used for anything, for WebSocket, for SMTP, for HTTP. And now suddenly, like, you need to write a parser. No, that's a bad idea. But then, completely by accident, like I stumbled upon a thread on GitHub that you can actually import native Node.js HTTP parser it's just kind of hidden. It's published, but it's hidden. It's like in a special underscore HTTP common module, which is a built-in module in Node. And there's a parser. And I was like, yes, let's give it a try. So I gave it a try. It was a complete disaster. And then in half a year, I gave it another try, and then another. And then eventually, we arrived at this layering that made sense. So what we do now is we have this mock socket class, which is just a pass-through socket. Doesn't do anything by default, but it lets you know when data is written and read from the socket. And then we wrap it in a more specific class, which is mock HTTP socket. And this one uses the Node.js parser. So suddenly all this data from the socket is going through the parser. And we know when certain requests are happening, when responses are happening. And this is where we translate them to fetch API counterparts. And then on top of that, we construct an HTTP agent, and then we hook it to the HTTP API that I mentioned before. So we're still kind of activating on this middle layer, but the way requests are routed are from the socket, from the underlying socket. I don't think we can even go deeper because it wouldn't make sense. And this is almost perfect, and I'm very happy that we have this API. It's quite groundbreaking. I haven't even announced it yet, I think. I think this is the first time I'm talking about it in such a detail. I have a long blog post ready, but yeah, I need to publish that. So basically, what I was trying to say is that there's different ways to intercept requests. So we can rely on standard APIs like Service Worker in the browser, and we can come up with something ourselves, since there's nothing better in Node.js, to have kind of the seamless way of handling requests, no matter how they were constructed.
Did going to that lower level unlock like new types of things that you could mock that previously were like too hard or cumbersome to?
I think, first of all, it unlocked more of the network code for everybody consuming MSW. Now your code will create this client request instances. It will actually create sockets, which wasn't the case before. It will actually push the data and read the data. And to me, that matters a lot. Basically, the closer I can get people's tests and demos and anything working to production, the better. Because now what it did, it unlocked a bunch of bugs that people found that wasn't there. And I love this about MSW. The more we bet on the standards, the more we try to kind of be less intrusive as possible, the more people find this little kind of hidden bombs they have in their code or in their tests that just wasn't there. Because if you enter this black box, suddenly, yeah, everything is nice and shiny and passing. But if you allow more code to run, hey, you find a kind of inconsistency here, or you're actually making a request that doesn't make sense per spec, but because everything before was just giving you thumbs up, go ahead. Yeah, you thought everything's okay, but with this lower level interception, we are utilizing more of Node.js, which is really important. We actually found some bugs in Node.js too, which I love, so we can improve and everybody can, move towards better ecosystem in general. As in terms of like features, I'm trying to think if there was something that was related feature-wise. I don't think so, but we did the foundational work to potentially allow things like mocking SMTP in Node.js. For that, we also need a parser, but hey, maybe that's something for the future to consider.